Hi everyone, welcome back. Today we are going to see an case study on why the moving coil instrument are used for the measurement of DC voltage and current, and it is not used for the measurement of AC voltage and current. So let's see the introduction of both moving coil and moving ion. And moving ion instrument which are used for the measurement of DC voltage and current, and moving ion instrument which are used for the measurement of both AC and DC voltage and current, which were already studied in the operation of moving coil and moving ion instrument. So the both moving coil and moving ion instrument which are very essential to measure the electrical quantity such as voltage and current in both AC and DC. So already we've seen the operation, construction and operation of moving coil and moving ion. Just a brief out, summarize the few things about the operation for the remembrance. So this is a permanent magnet moving coil. It is permanent magnet means the north and south pole are the permanent magnet, and moving coil is nothing but in between the two electromagnet and a rectangular shape or squirrel cage type coil will be there. The coil, it has a property of moving, so it is called permanent magnet moving coil. So because of the interaction of the fluxes in the moving coil gets rotated. So if the coil gets movable, the spindle is also gets movable. Once the spindle is movable, so the pointer gets movable from 0 to some value. Okay, so this is the operation, and these are the advantages of the moving coil instrument. Here the scale from starting value to ending value, the scale is always uniform, and it requires very small value of current for the operation of MC instrument, and very small amount of change in current, it produces a necessary deflection in the instrument. That means high sensitivity, and so it eliminating the damping which is produced by the moving coil instrument, so that effective damping will be provided, and the accuracy is also good. If you want to extend the range from 150 to 300 or 300 to 600, that is possible in the MC instrument, and it is not affected by some external magnetic field. And these are the disadvantages. The main disadvantage is it is not used for the AC measurement. And if you go for the moving ion instrument, so in the moving ion instrument, so this is a coil. If the coil is getting energization, it acts as an electromagnet. This electromagnet, it attracts the ion pieces, moving ion. So because of this electromagnet, the ion pieces gets attracted. So this movement of ion is nothing but moving ion instrument. So during this movement, pointer, spindle, everything gets movable across the scale, so that everything, the way all the setup will gets movable. Once the power is interrupted, so with respect to the control weight and the balance weight, again it moves to the original position. So it not comes immediately, it slowly count down because of this air damping chamber. And what is the advantage means, here the moving ion instrument can be used for both AC measurement as well as DC measurement, and it produces very high operating torque, and the construction is very simple and very robust, and accuracy is also very good. So it is cheaper than the other instrument. It can be operated at any frequency range. What is the main disadvantage means, the scale is not uniform, and for lower power range, power consumption is higher. So these are the disadvantages of instrument. And when compared to the objective, why it is not suitable for the AC measurement. Okay, so now this is a moving coil. So for the indicating instrument, here we are in need of 3 operating torque. One is nothing but deflecting torque, controlling torque, and the damping torque. So here the deflecting torque is nothing but TD is equal to NBAI, number of turns in the moving coil, the magnetic flux density produced on the moving coil, and area of the conductor of the moving coil, and the current flowing through the moving coil. So from this NBA, all are constant, high is only the variable. And if you go for the controlling torque, so the controlling torque is directly proportional to the deflection of the pointer. So in order to cancel the proportional, we are multiplying the constant K. So for the final indicating value, both the deflection torque and the controlling torque both are equal, so that NBAI equal to K theta. So K theta is equal to NBAI by K. So from this, so NBA, K, everything is constant, so only variable is theta. So from this, we are getting the theta is directly proportional to height. Similarly, from the moving ion, here we are getting the theta is directly proportional to I square. Here I square. These are the difference. Okay. So let's see. Now, if you see this equation, now if I am applying the current of 2 amps DC, if the current is 2, the deflection is 2, and here the current is 2, when we squaring the current, here we are getting the deflection is 4. So here we are getting the deflection as 2, and here we are getting the deflection is 4. So both moving coil, moving ion can operate under DC. And if we go for AC, so this is positive 2 and this is negative 2 amps. 2 amps. Okay. So here if you are applying the plus 2, the deflection will be 2. If the current is minus 2, the deflection will not come under negative region. So that the moving coil is not work under AC. Okay la. So AC means the under negative region, it doesn't go negative region. Okay. But if you go for moving ion, here the current is plus 2. When we are squaring the value, we are getting the deflection as 4. And if the current is minus 2, if we are squaring the minus 2, here also we are getting the deflection is 4. So whatever the value, whether it's positive or negative, the deflection is always positive. So that the moving coil is only for DC, and the moving ion, it is used for DC as well as AC. And these are the few textbook for this case study. Thank you.